So today we're going to talk about lesson 7, which is on absolute value inequalities. Okay, so absolute value inequalities, the way you recognize them are, and you can see down here in the bottom, they have the absolute value symbols, so those little vertical lines, and then they also have the greater than, less than. They're not equations. All right, now as soon as you see one of these, you have to think to yourself, wow, not only am I going to have inequality rules, but I'm also going to have absolute value rules, which always involves two different like setups with those little arrows. Okay, I always draw mine the same way, so they always look the same. So today what we're going to do is we need to remember kind of a little acronym, which is we use the word greater. Okay, so I have this written out, greater, because anytime the symbol is either greater than or greater than equal to, we're going to have to incorporate an or into our inequality statement. Less than or less than equal to kind of sounds like less than, similar, not exactly the same. These are going to involve incorporating an and into our solving, okay? So the steps to solve these are pretty simple. Number one, first thing we're going to do is we're going to isolate the absolute value, okay? So I'm going to highlight this because I want it to look like we did before. So what that means is that absolute value has to be by itself. So if we look down here at our examples, number one, absolute value is by itself on one side. But on number two, absolute value is not by itself. So we would have to isolate it first. We would have to do some algebra first. Okay? So the first thing we're going to do is we're going to isolate absolute value. The next thing that we're going to do is we're going to set up two, so I'm going to draw my little arrows like I always do, inequalities. Okay? If I have greater than or greater than equal to, in between I'm going to use or. If I have less than or less than equal to, I'm going to use the word and between them. All right? So, and as a review, these are going to result in what we call C-O-U-M-P. Oops. Maybe I can spell correctly. C-O-M-P. We're going to solve some compound inequalities out of these. Okay? And then we're going to have to graph our final solutions on a number line. I am also going to clarify and say that this is going to be or in pink, and blue is going to be my and. And my blue pen is not working now. Ay, ay, ay. Okay, so starting with number one, all right, I'm going to put a check mark here like I always do. Notice I have absolute value by itself. So I'm going to put a check mark to show that I accomplished step number one. Now I'm going to set up two inequalities. My first inequality is going to be 3x minus 4 is greater than 12, exactly what I was given. The second is 3x minus 4 is less than, so notice I have a sign flip, and I also change the number sign to negative 12. Since this is a greater symbol, in between here, I'm going to use the word or. All right? So at this point, it has now become exactly like all of the problems that we have done before with compound inequalities. We solve them, we graph the answers on a number line. Just as a little note of reference up top, typically your or statements are going to look like something that comes to the outside like this. They should have the same symbol. Your and statements are probably going to be between two values. All right, they're the middle sections. And this is typical. This is 90% of the time, that's what your solutions will look like. So when I'm down here, I can go ahead and solve each of these. All right, so I draw on my little wall here. I add 4. 3x is greater than 16. Divide by 3. X is greater than 16/3. Or if you put it in your calculator, this is approximately 5 1/3. Okay. Then I still have my or, so I'm going to write that in between. Then I'm going to solve this one. I'm going to add 4. Here's like my little wall. 3x is less than -8. Divide by 3. X is less than -8/3, which is about 2 2/3. -2 2/3. So on my number line, I have greater than 5 1/3. Open circle, shade right. And then here I have less than -2 2/3. Open, less than, shade left. So my final answer is all of this. Any questions? I don't see any hands. If so, you can always raise your hand on the actual chat box and it'll pop up on my screen. All right, so let's do the next one. Try to get you through these pretty quickly. Okay, so for the next one, my directions say to isolate absolute value up above. I don't have that by itself. So remember, a number right next to that absolute value is going to be times. So I'm going to divide both sides by 10. Now I've accomplished my task of isolating absolute value. According to my steps, I'm going to set up two equations, one to the left and one to the right. X plus 9 is greater than 5. This is greater, so again, I'm going to use the or. And then x plus 9 is less than -5. Go switch the inequality sign, switch the number sign of what's on the other side. Solve each of these. -9. -9. And put the or back in the middle. Set up our number line. X is greater than -4. So maybe I stick -4 here. Open circle, shade right. X is less than -14. Open circle, shade left. Okay, final answer, both of those regions. Okay, let's move down to the bottom. We'll do example 3 and 4. So, for example 3, here's the question. If this is my wall, do I have absolute value by itself? The answer is no. So to isolate absolute value, I'm going to subtract 10 from both sides. Now I can put a check mark because I've accomplished isolating absolute value, step 1. And now I can set up my two separate inequalities. X minus 8 is less than or equal to 12, exactly what I was given. But now I have a less than. Less than translates to the word and. Let's see if I can grab a different blue pen. It won't be as pretty, but it'll be there nonetheless. And. All right. Over here, I still have an x minus 8, but then it switches to greater than equal to and negative 12. So here are the two switches that I have. And then I can solve plus 8 plus 8 in the middle I have an and. So this is where we want to take a second and think, okay, and was the middles. X is less than 20, but it's greater than or equal to negative 4, less than or equal to 20. So on my number line, when I set this up, I'm going to want to put my high number as 20 with a solid circle now because I have an equal sign. And then I'm going to use negative 4 as my low number. Again, I have an equal sign. And my region is going to be in between the two, which is in here as my final solution. Right? If you've been very good with your algebra up to this point, I don't think these are particularly hard, but I do want to put a star by the next one. Maybe 2 stars, 3 stars. Because one of the things about inequalities is the golden rule of inequalities always applies. So here's what I mean by that. If I want to look at this problem, that is my absolute value. Here is my wall. In order to solve for absolute value, I have to divide by negative 3. Now remember, I'm only in step 1 right now. I'm not into the solving and the final solutions. Okay? I'm only in step 1, but the golden rule still applies. So when you see this, I divided both sides by negative 3. This is that golden rule. So yes, I bring down my 2x, but now my less than or equal to becomes greater than or equal to. This becomes a 7. And now, because this is a greater, that tells me that I'm going to have an or in the middle between my two separate inequalities. So go through this very much step by step. Take a breath. That's why I'm not giving you a lot of problems for your homework. I really, really want you to take your time and do them correctly. Think through them, especially if you get them wrong on the first try. So let me show you again. 2x greater than 7. This is the symbol I use, which matches to the or statement. 2x greater than or equal to 7. 2x less than or equal to negative 7. So the process is solving, follow the rules. Take this, set up the 2, choose the correct word based on the symbol here. And now we solve. So this one's a pretty easy one-stepper. X is greater than or equal to 7/2, which is approximately 3.5. X is less than or equal to negative 7/2 or negative 3.5. Draw my number line. Greater than 3.5, so here's 3.5. Solid circle because it's equal. Shade to the right. Less than negative 3.5 or equal to, solid circle. Shade to the left. Final answer. Any questions on that? I don't see any hands. All right, so now we're going to get to the exciting, riveting problems, which are the hardest type that you will have. I believe you have 3 of these in tonight's assignment. So there's 3 easier ones and 3 of the harder ones. All right, now, at the top of this page, I typed out the directions that we went over on the previous page. So I used a lot more words and explained it just in case you didn't write it down. It's very clear what the directions are. You can use these when you do your delta math. You could just put a plain piece of paper over top and you can just follow them for every single problem. Okay, so we're going to isolate the absolute value expression. So I'm going to put that in the orange just for a visual cue. So when I look over here and I draw on my wall, I have a lot going on. Take a look. Okay, I have a 4 times in the front, and I also have a -1 at the end. In order to solve these, we're going to first move the 1 to the other side. So I'm going to add 1 to both sides. Then I'm going to divide both sides by 4. And think, I divided. Is this the golden rule? Not the golden rule. So I'm just going to put a note here. Not the golden rule. Okay? So this will stay the same. 2x minus 3 is less than 3. Now, take a look. Here's absolute value. Here's absolute value. I believe I have accomplished step 1, finally, which is isolating absolute value. And notice I added or subtracted first, and then I multiplied or divided. And now I'm back to my new section. This is a less than, so that's going to be an and. So this is my and between them. That came from what I learned today. And now I'm going to set up my 2 separate inequalities. Switch the symbol and the number sign. All right, add 3. All right, bring down the and, just because I want to make sure I don't forget that. Add 3. Number line. Now remember, anytime we have and, we want the middle section. And is the middle. It's the glue that holds the 2 parts together. So less than 3 and greater than 0. 3 is a key value. 0 is a key value. And I want to shade up the middle. And I'm done. That's the solution I'm looking for. All right, last one. Okay, this is as hard as they get. I didn't give you anything harder than this. Draw on the wall. Isolate absolute value. -3. Divide both sides by -2. Is this the golden rule? Ooh, streamers should be falling from the sky. Balloons could be going off. The answer is yes. This is the golden rule. So I'm going to take my less than, I'm going to turn it into greater than, bring down my 3x plus 7, bring down my 1. All right. So initially, just like in number 4, I used the golden rule to go from less than to greater than because I divided both sides by a negative. Moving down here, I'm going to set up my 2 equations. In between, greater is going to be an or. So this is my or statement, OR. It's right up here, greater, or. So that goes there. 3x plus 7 greater than 1. 3x plus 7 less than -1. Okay, I don't know why I wrote a 6 there, but we're going to isolate by subtracting 7 from both sides. Dividing by 3. Remember, this is not the golden rule here, because I divided by 3, -7, (8/3) is approximately 2 2/3 negative. Draw my number line. Okay, remember in between I have an or. So my answers should be those outward facing number sets. Right? So when I go to graph this, x is greater than -2. Here's -2, open circle, shade to the right. So this is here. X is less than -2/3. Open circle, shade to the left. And I'm done. Those are my final answers.